Hello friends, welcome to the channel Physics by IITians. So this is our next lecture of electrical image method. Okay, so in the earlier videos we have already learned that electrical image method part 1. So I request you please watch that video first, okay, then come to this video. So let's start the video. So first of all, let me take this pen. Okay, so I should choose the pen color, okay, as blue. Okay, so we have already known, we have already demonstrated, I have already told you that what is the method of image, what is the method of separation of variables. Okay, so first of all you should know, okay, what is the method of image. That is, there are discrete charges, the conducting bodies of simple boundary. And now in the case of method of separation of variables, the potential of conducting bodies is given. You have to solve differential equations subjected to the boundary conditions. Okay, so suppose we are taking an example first. This is a very important question actually. So you have to determine the system of image charges that will replace the conduction boundaries that are maintained at zero potential for an infinite line charge located midway between two charges intersecting conducting planes forming a 60-degree angle. Actually there are two conductors and these are conducting planes and they are forming angle 60 degree and there is a charge. So the question is, how many image charges will be formed due to this particular charge residing residing in between these two conductors. So if there is a point charge and it is located between two parallel conducting planes, okay, the conductors are not, suppose they are not making an angle of 60 degree, but they are parallel. So how many number of image charges? The number of image charges actually that will become infinite. So whenever a point charge is located between two intersecting conducting planes that is forming a theta angle, then 360 divided by theta is n and the number of image charges will be n minus 1. So here suppose this theta is 60 degree. So 360 degree by 60 will be 6. So n minus 1, that is 6 minus 1 is 5. So 5 will be the number of image charges due to this charge. So this is 1, 2, 3, 4, 5. Okay. So whenever this kind of configuration is given and you are asked that find the number of image charges, you have to apply the formula. So here we have an announcement that if you are a candidate for the PhD, integrated PhD physics, so you can join our test series, full length test series, subject wise test series, all are activated, and these tests are extremely helpful for preparation of NET, GATE, JAM, TIFR like examination. And we have also special interview guidance package for cracking integrated PhD or PhD physics interviews, and also MTech interviews, MS interviews. We'll take mock interviews, we'll clarify your concept, and it costs only 699 rupees. And for more information, please contact us on Telegram. So let us take an example, another example, the method of images for a spherical conductor. So suppose we are taking a point charge and a grounded conducting sphere. So let us take the point charge Q located at A. Okay. So consider a point charge small q placed at a distance d from the center of grounded conducting sphere of radius A. Now the potential at any external point P, which this is the point P, okay, which is r and theta coordinate, will be partly, this potential on this point will be partly due to this real charge Q and due to the induced charge on this conducting sphere, and this is grounded. So to solve the problem by the method of image, we have to replace the induced charges by suitable image charges, and the symmetry of the problem suggests that we have to take the induced charge along the center of symmetry, that is the here along the line of symmetry, that is OA. Okay, so let us take the image charge. I am taking this as red color. So let us take the image charge Q prime located at B distance, and OB is D prime, okay, and OA is D. Clear? So you have to also understand that in this atom they must satisfy some certain boundary conditions, and the well-known condition for all of us that the potential surface for this conducting sphere, this is 0. because conductors are here. This is a grounded conducting sphere. So this is equipotential surface. So here the potential will be 0. So if you find the potential at any point on the surface of the sphere, then it must be equals to 0. So we can write that 1 by 4 pi epsilon naught q by AC plus q prime by BC equals to 0, where q, this term, is due to the real charge and q prime term is due to the imaginary charge. And by just putting these coordinate values, AC in forms of A d cos theta and BC in forms of A d prime cos theta, you will get that Q prime, that is the value of the image charge, is minus Q into A divided by D, and D prime is the distance of the image charge from the center of the conductor, the conducting sphere, is A square by D. So I highly suggest you to remember these two formulas. And you should understand also how these formulas have come from. Okay. So if you find out the components of E, that is electric field component, is ER and E phi, E theta, you will get ER is minus del phi del R, will be this one, and E theta is minus 1 by R del phi del theta, will be this one. Why I am not going to tell all these things? Because you will get this kind of problems or this kind of derivation in any standard book. I request you, just go to, if you want to understand the derivation part, just go through the book. Otherwise the video will be more lengthy. Okay. So what will be the lines of force? So you all know that whenever there is a positive charge, that is the real charge, and the negative charge will of course be the imaginary charge, will be negative charge. And also I have got that imaginary charge, that is Q prime, is minus QA by D. So the lines of force from positive to negative, and they should enter the conducting sphere perpendicularly, right? So that's why the lines of force line will be this way. Now why there is a dotted line? Dotted line because inside the conductor the electric field is actually 0. So there is no kind of real electric field inside the conducting sphere. So we have denoted it by dotted line. So what will be the force on positive charge plus Q due to this induced charge? So if you want to know the force, then you have to take simple Coulomb law, that is F equals to 1 by 4 pi epsilon naught Q into Q prime divided by BA square K cap, where BA is the distance between the image charge and the real charge. Okay, so you will get the force as minus q square AD by 4 pi epsilon naught D square minus A square whole square K cap. And this force is attractive in nature because this is a negative charge, here is the positive charge, so this force is attractive. Now if the distance is very much less, that is this charge Q is very much closer to the sphere. Okay, so we can write that D, that is the distance between the this O to A distance, is actually D. So we can write this, the distance between O to A, that is OA, is D equals to A plus delta, where A is the radius of the sphere and delta is a very small distance, that is delta is nearly equals to very less than A. Then F is nearly 1 by 4 pi epsilon naught minus 1 by 4 pi epsilon naught Q square by 2 delta whole square K cap. So the result is similar to the case of point charge in front of a conducting plane. So wherever we are taking, suppose what it has been given here. So if you just reduce this distance, okay, so suppose this charge is now here. So this, if this is a very large sphere, so the radius of the sphere is much larger, and it will feel that okay, this much portion will be visible to this charge, and it will treat like a plane conductor, not a sphere. And in case of plane conductor, the object charge distance is equals to image distance. So 2d will be the 2 delta will be the distance between them. So it will resemble to the case of the plane, conducting plane. Okay. If you want to find out what will be the amount of induced charges, so for the finding out the amount of induced charges, let us take the surface density of this induced charge at any point on the surface. The point we have taken as C, and C is A theta, the coordinate of C. So what will be that? That is sigma theta is minus epsilon naught into del phi del R, where R is at A. Okay, so it will become phi, also we have find out. So found out, so it will become minus q by 4 pi a d square minus a square by a square plus d square minus 2ad cos theta whole to the power 3 by 2. So as expected, the induced charge density is negative. So now here, since the charge is also negative, image charge is negative, so induced charge will also be negative. Okay, so it is totally the same. Now note here that a square plus d square minus 2ad cos theta, this is AC. So this to the power 3 by 2 is AC cube. Okay, root AC actually. So we can say that the charge density at any point is inversely proportional to the cube of the distance of the point from charge q. So what will be the charge density for the maximum? That will become when theta is 0, and charge density will be minimum when theta equals to 180 degree. So sigma max, that is theta is 0 degree, it will become minus q by 4 pi a d plus a by d minus a whole square, and sigma mean, that is theta equals to 180 degree, that will become minus q by 4 pi a d minus a by d plus a whole square. And look here, sigma cannot be 0 at any point on the sphere. Okay. So if you find out the total induced charge, that is q, on this sphere, what will happen? Of course, it will become the image charge. Okay, so just put the value that q, you have to take the integral over 0 to pi sigma function of theta into 2 pi a sin theta a d theta. You will get the total amount of induced charge, that is minus qa by d, which is exactly equal to the image charge, and all our assumptions are actually right. So whatever we have learned here, that whenever there is an induced charge, in case of this kind of in conducting plane, conducting sphere, we can take an imaginary point charge, and that has the same value just like the induced charge. Okay. So there is a free test link in our portal. If you test in our portal, you have to log in, you have to register in this link, and then you can give your test for your benefit. Okay, so the full solutions are also available in your free test also. Let us take an example which has already come in NET paper. So the question is, a charged particle is at a distance d from an infinite conducting plane maintained at zero potential. When released from rest, the particle reaches a speed u at a distance d by 2 from the plane. At what distance from the plane will the particle reach the speed 2u? First, understand the question. Here a charged particle, and it is at a distance d from an infinite conducting plane maintained at zero potential. So whenever the charge first it was raised, now you are releasing the charged particle, and the particle will reaches a speed of u at a distance d by 2 from the plane. Now what will be the distance from the plane when the particle reaches the speed 2u? So first of all, you should understand this is the image. You can find out the answer by applying the image technique. So let us take that x is the distance of the charged particle from the plane, and so the image charge will appear, that is also the distance will be x but behind the plane. So what will be the force on this charged particle? That is q by 4 pi epsilon naught q square by 4x square, as the distance between them is 2x. So the equation of motion will be m d2x dt2 is the Coulomb force, that is 1 by 4 pi epsilon naught q square by 4r square. So you will get x double prime equals to q square divided by 16 pi epsilon naught m into 1 by x square. So multiply this both side by 2x dot. You will get d of x dot square equals to q square by 8 pi epsilon naught m dx by x square, and finally you get x dot square equals to minus q square by 8 pi epsilon naught m 1 by x plus c. Now at x equals to d, the distance, that is the initial distance, the x dot, that is the acceleration of dx dt, that is the velocity of the particle, is 0 because it was initially at rest. So c constant will be q square by 8 by epsilon naught m into 1 by d. So what we will get? You will get x dot square is q square by 8 pi epsilon naught m 1 by d minus 1 by x. So x dot square, that is velocity square, is proportional to 1 by d minus 1 by x. Now the question is, at what distance from the plane the particle reached the speed 2u. So you can compare this two velocities u and 2u. How? You just put this relation that x dot square, when it will attempt u, okay, so it will become 1 by d minus 2 by d, because the distance is d by 2, okay, because x will become d by 2. Let me take this pen. So at whenever it is the velocity is u, the x distance will be d by 2, so it will become 1 by d minus 2 by d. But whenever the velocity is 4u square, you don't know the distance, so let us take x as x prime. So you will write as 4u square into equals to 1 by is proportional to 1 by d minus 1 by x prime. So you take this two proportionality and you just take the ratio of these two speed, that is u square by 4u square is equal to 1 by d minus 2 by d divided by 1 by d minus 1 by x prime. So you will get x prime as d by 5. So do you understand what you have done? You have done here, first find out that the force it is experiencing, it is the giving the charge to for the motion, that is m into mx double dot, that is the force is due to the Coulombic force. So you equate these two forces, you find out the relation, that is x dot in terms of x and d, that is you get x dot square is proportional to 1 by d minus 1 by x. Now you know the value of x dot square, that is u, whenever the distance x will become d by 2, and you have to find out the value of x when the x dot will become 2u. So you have to take the ratio and you will get the final answer. Let us take another example. So the question, the 2 point charges of, let us take this pin, okay, let me take it. I am choosing this color, green. So 2 point charges plus 3q and minus q are placed at 0,0d, 0,02d respectively above an infinite grounded conducting sheet keeping in the xy plane. At a point 0,0z, where z is greater than d, the electrostatic potential of this charge configuration would approximately be how much? So there are two charges. One is plus 3q, it is located at 0,0d, and another charge is minus q, located at 0,02d. What you have to find? You have to find out the electrostatic potential of this charge configuration. So find out what will be, how many are image charges there. This is for the plus minus q charge, there will be exactly opposite image charge, that is plus q, and for this plus 3q charge there will be exactly opposite charge, that is minus 3q, and you have to find out, you have to consider all these interactions, all this potential, okay. So the charge potential at a point 0,0z will become 1 by 4 pi epsilon naught minus q by z minus 2d plus 3q by z minus d minus 3q by z plus d plus q by z plus 2d. Okay. So let us take what are the coordinates. So let me erase it out. Click here. This is the 0,0d. This one is the 0,0d. This one is the 0,02d. This is 00d, 002d. This is 00 minus d. This is 00 minus 2d. Okay. So 1, there will be minus q. Here this is 2d distance. So if you take this as z coordinate, so the distance will be z minus 2d. Okay. This distance is z. So it will be for this charge, this is z minus 2d. Okay. For this 3q charge, that is plus 3q charge, it will become z minus d because it is at 00d. For this 3q charge, that is minus 3q, it will become z plus d. And for this plus q charge, it will become z plus 2d. Alright. So you find out the potential as q by 4 pi epsilon naught z square into 2d. So this is very simple. Just you have to understand how to find out the image charges, how to find out their positions, and how to take their potential or the charge distribution. That's all. So this is your homework. I Read this question. Four charges, equal charges plus q, each are kept at the vertices of a square of side r. A particle of mass m and charge plus q is placed in the plane of the square at a short distance a from the center. If the motion of the particle is confined to the plane, it will undergo small oscillation with an angular frequency. These are the four options. Actually, I have given here the solution also, so you can go look upon this solution also, but I highly recommend you to do this by your own. Okay, so answer will be C. So thank you so much for your cooperation. We hope you value our time and efforts and help the needy students too. So please do share our videos, subscribe to our channel, because we believe the sharing of knowledge is the best way of helping the society. So thank you so much. You can give a test link in our portal. Free test link is also there. Subject wise paid test and full length test are also there. Interview guidance are also there. Full solutions are available. Keep sharing our videos. Watch these videos. Thank you so much.